The next question is question number 44. This question is, consider a polygon of n sides. Triangles are formed by joining the vertices of the polygon. Then which of the following is not true? He is giving us 4 statements. We are supposed to select that statement which is not true. It means that 3 of the statements might be correct. Therefore, it is full informative, a valuable question it is. Let us go through the options. The first option is the total number of triangles is NC3. The second option, that is option B, is number of triangles with exactly one side in common with that of the polygon is n into n minus 4. The third option is number of triangles which have 2 sides in common with that of the polygon is n. And the number of triangles which have no sides in common with that of the polygon is 1 by 6 into n minus 4 into n minus 6. Let us examine which option is correct. He is giving us a polygon of n sides. For better verification, let us choose a polygon of our liking. Well, let me take a hexagon. According to our wish, I have taken a hexagon. That is, in my view, n is 6. n is 6. What is the first? How many vertices are there? 1, 2, 3, 4, 5, 6. 6 vertices are there. These are the vertices of a polygon. That is, no 3 of them are collinear. No 3 of them are collinear. Let us check the first option. What is it? The number of triangles is NC3. Is it correct? Correct, of course. Why? Because here it is a hexagon. How many vertices are there? 6 vertices are there. Out of these, 6C3 is the number of triangles. It is correct. Why? Because to have a triangle, you must be provided with 3 vertices. There are 6 such. You choose 3 among them. It can be done in 63 ways. Therefore, the total number of triangles of 6 sides is 63. The total number of triangles in a polygon of n sides is NC3. So, option A is correct. No problem. We are not supposed to choose the correct option. We are supposed to choose the incorrect option. So, let us now think of the second option also. Number of triangles with exactly one side in common with that of the polygon. Let us now have a check. Let me name this A, and B. How many triangles will be there with this AB as a common side? Well, if 2 vertices have already been chosen, you are to select one more vertex. If you choose C, what is going to happen? In the triangle ABC, 2 sides are in common for the polygon and this triangle is formed by joining the vertices. No, we are not supposed to have 2 sides in common. We are supposed to have only one side in common. So, you are not supposed to choose C and this also. Therefore, this is a triangle and this is another triangle. Observe these 2 triangles. Observe these 2 triangles. These 2 triangles have just one side in common. One side in common with that of the polygon. Therefore, only 2 are possible. Well, do not get interested in the number of such things. You get interested to know the style of getting them. To choose these triangles, you have omitted these 2 vertices and these 2 vertices. How many vertices have been remained? Still 2 more vertices are there. From those 2, you have chosen one in 2C1 ways. That is 2 ways. Isn't it? Well, in general, let this be a polygon of n sides. Be a polygon of n sides. One side is here. To have a triangle, To have a triangle, you must choose one more vertex. From where you are supposed to choose that vertex? You have to leave these two vertices and you have to leave the adjacent vertices also. All together, how many vertices are to be omitted? 4 vertices are to be omitted. What is the total number of vertices? N. You have omitted is 4. The remaining is n minus 4. Is n minus 4. Therefore, the third point can be chosen in how many ways? N minus 4 ways. Provided there are n sides, you have to choose one side, that can be chosen in n ways. Therefore, the side can be chosen in n ways and the third vertex can be chosen in n minus 4 ways. All together, what is the total number of triangles? N into n minus 4. Therefore, the answer is n into n minus 4 and here it is 6 into 6 minus 4. That is 12. Why? With AB as the side in common, we have 2 triangles. With BC as a side in common, you will have 2 more triangles. With CD, with this as a common side, you have 2 more. Like that, how many such triangles can be had in this diagram? 12, of course. And in general, the answer is n into n minus 4 is of course correct. By observing that the second option is also a correct option, we could have had a beautiful formula of the number of triangles in which the number of triangles joining the vertices of a polygon of n sides in which there is just one side in common with that of the polygon is n into n minus 4. Beautiful formula. We could have derived it. Yes, we could have derived. That is about the second option. Now, let us think of this third option. What is the third option? Number of triangles which have 2 sides in common with that of the polygon. Number of triangles which have 2 sides in common with that of the polygon. Observe the diagram once again. Let me take these 2 as the sides common to those triangles which are going to be formed. So, you just join these. This is a triangle in which 2 sides are in common with those triangles formed by joining the vertices. What has happened here? You observe. To have such triangles in which 2 sides are common, it is just enough to select 3 consecutive vertices. 3 consecutive vertices, that's all. If you can choose 3 consecutive vertices, you are going to have a triangle of that sort that has been explained in the option C. Right? How many ways you can choose 3 consecutive vertices? You observe this diagram. How many vertices are here? 6 vertices here are there. You can choose 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 1, 6, 1, 2. How many ways? 6 ways. As it is a hexagon, we are able to choose 3 consecutive vertices in 6 ways. If it is a decagon, we can choose that in 10 ways. If it is a polygon of n sides, we can choose in n ways. Correct. Therefore, the third option is also correct. The number of triangles which have 2 sides in common with that of the polygon is n. Excellent. We could have derived 3 formulae. In the first option, total number of triangles is NC3. In the second option, the number of triangles in which there is exactly one side in common with that of the polygon is of course n into n minus 4. And in the third option, the number of triangles which have 2 sides in common is just n. According to logic, as the first 3 options are correct, the incorrect option present is D. So, according to logic, it is correct. Logically speaking, the 4th option is the right option. We could have answered it. This is over. question is over. But of special interest is the case to go through the fourth option. What is the fourth option? Number of triangles which have no sides in common with that of the polygon is. He has given one particular answer. Our logic has said that it is incorrect. Then what is correct? Let us know. That becomes another formula that can be thrown into our knowledge bank. Yes, let us now find the number of such triangles which have no sides at all in common with that of the polygon. Let us do that. That is, we are interested to know the correct form of the fourth option. Actually, he has asked to locate the incorrect option. Option D is incorrect. We have done it. The question, answering the question is over, but we have taken special interest to know the actual number of triangles which have no sides in common. How can we obtain that? What is the total number of triangles? Answer 3. From this total number of triangles, some things are to be deleted. What are the things to be deleted? Number of triangles with one side in common, number of triangles with two sides in common. Those two are to be deleted. Number of triangles with one side in common. What is that? N into n minus 4. N into n minus 4. And what is the number of triangles with the two sides in common? N. These are to be deleted. These are to be deleted. So this is n into n minus 1 into n minus 2 by 3 factorial means 6 minus, you get n out, n into n minus 4 plus 1. Well, what will be the LCM? 6 is the LCM. N into n minus 1 into n minus 2 minus 6n into, what is n minus 4 plus 1? N minus 3. N minus 3. Good. Again, getting n as common factor. What are you going to have? N minus 1 into n minus 2. That is n square minus 3n plus 2 minus 6 into n minus 3. 6 into n minus 6n. 6 into 3 plus 18 by 6. What are we going to have? What are we going to have? This is n into n square minus 3n minus 6n minus 9n plus 2 plus 18 plus 20 by 6. And it is a very easy matter to factorize that expression which has been involved in the square brackets. You can see that n into n minus 4 into n minus 5 by 6. We could have successfully derived a new formula of getting the total number of triangles in which no sides are common at all with that of the polygon. That is n into n minus 4 into n minus 5 by 6. But in the fourth option, he has said that the number of such triangles is n into n minus 4 into n minus 6 by 6. There lies the mistake. That is why the fourth option, that is option D, is wrong there. Yes, even though answering the question is already over, if you try to get the correct answer for that option, then you will be knowing a new formula to have the number of triangles in which no sides are common with that of the polygon. It is n into n minus 4 into n minus 5 by 6. In the next occasion or in the next question, you may be asked to have the number of triangles that can be formed by joining the vertices of an octagon which have no sides in common with that of the polygon. What is that? It is just enough if you can substitute 8 in the place of n. What is the answer? 8 into 8 minus 4 into 8 minus 5 by 6. You calculate and get the answer. That is why we can think of the question a full informative question that must be possessed, that must be contained in our brain. You can throw all this concept in the knowledge bag. Yes, that's all about the question. Of course, the right option is option D. The next question before us is, that is question number 45. The total number of 6-digit numbers that can be formed having the property that every succeeding digit is greater than the preceding one is first option 84, second option 36, third option 126, fourth option none. Let us understand the question very carefully. The total number of 6-digit numbers that can be formed having the property that every succeeding digit is greater than the preceding one. So much of information has been involved in the question or the sentence given in the question. There are 6 digits. Is it possible to observe any repetition of the digits? No. Why? Because one digit is strictly greater than the previous digit in the sense which lies in the preceding place. No question at all the digits are distinct. Otherwise, such increasing order cannot be observed. Moreover, none of the digits is 0. None of the digits is 0. Why? Because suppose six-digit number you have to have. Naturally, in the first place, you cannot take 0. You cannot take 0. Definitely a non-zero digit must be placed. Suppose some 2 is present. Here the restriction is 0 cannot be entered in any of the remaining places also. Why? Because if at all you take some 0 here, this cannot be greater than this preceding digit. It cannot happen. Therefore, 0 cannot be used at all in any of those 6 places. In any of the 6 places. Well, by following the information given in the sentence of the question, we are granted about 2 particular things. Number 1, all the digits are non-zero. Number 2, all of them are distinct. Well, now the question is it the way of permuting or selecting? Let us see. 6 digits are to be selected first and then arranged. Let us first choose 6 digits in 96 ways. Why is it 96? All of the digits must be non-zero. How many non-zero digits are there? 9 non-zero digits are there. Out of those 9 non-zero digits, you can choose 6 non-zero digits in 96 ways. Okay, the digits have been selected. Once they are selected, they can be put in these 6 places in an increasing order. In how many ways? Only one way. In that particular order, you can choose 6 digits from the 9 non-zero digits in 96 ways. So selection is over. After selecting these 6 digits, you can place them in the 6 available boxes in one way only. Why? Because all these 6 are different digits. These 6 different digits can be put in an increasing order. Why should we have them in an increasing order? He has said it. What has he said? Every succeeding digit is greater than the preceding one. What does it mean? They must be arranged in an increasing order. After selecting 96 ways, that selection. Though in each selection, the selected digits can be put in an order, increasing order in one way only. Therefore, the total number of such numbers is 9C6 into 1. But 9C6 is 9C3. What is 9C3? 9C3 is 9 into 8 into 7 by 3 factorial is 6. This is 72 by 6 is 12. 12 7 is 84. What is the right answer? 84 is the right answer. So, option A, the first option is the right option, and the right answer is 84 for that question. The next question before us is question number 46. In this question, the total number of 3-digit numbers, the sum of whose digits is even, is asking us. How many digit numbers are required? 3-digit numbers are required. What is the condition given? Sum of whose digits is even. Is even. Okay, the options are option A 450, option B 350, option C it is 250, and option D it is 325. Let us examine that. Let the digits be P, Q, R. You are supposed to construct, rather form 3-digit numbers. What is the condition given? P plus Q plus R is even. This can be divided into 3 or 4 different cases. What are the cases? Case 1. P, Q, R are all even. With this constraint, how many numbers can be formed? Here, 3-digit numbers are to be formed. All the 3 places must be with even numbers only. What are the even digits available? 0, 2, 4, 6, 8. How many? 5 even digits are there. Out of those 5, first place can be filled in 4 ways only. Why? Because you are supposed to take a proper care. Enough care is to be taken about the first place, because 0 must not be there. Precautionary measure. It can be done in 4 ways. But the next one, 5 ways. Next one, 5 ways. Altogether, how many such numbers are possible? 4 into 4, 5 into 5, that is 20. Sorry, it is 100. 5 into 5 into 4 is 100. 100 such numbers are possible. Case 2. The sum must be even. Can P, Q, R are all odd be possible? No, not possible. 2 things are even, 1 is odd. Is it possible? Not possible. Why? Because then the sum will be odd. Then 2 things are odd, 1 is even. It is possible. P, Q are odd. Suppose P plus Q is even, R is even, sum is even. Yes, it is possible. P, Q are odd and R is even. How many such things are possible? The first digit is P, second digit is Q, third digit is R in our view. How many ways can you fill these 3 gaps now? First place, P is odd. What are the odd numbers? 1, 3, 5, 7, 9. Absolutely, these are all non-zero. Therefore, first place can be filled in 5 ways. Second place can also be filled in 5 ways, because it must also be an odd number. And what about the last place? It must be even. How many even digits are there with your disposal? 0, 2, 4, 6, 8, 5. Can you place 0 there? Why not? It is not the first place. You can put 0 there also. Therefore, this can be filled in 5 ways. Altogether, the total number of such numbers in this case will be 5 into 5 into 5, that is 125. Case 3. In case 2, you have taken P and Q are odd. Now we take Q and R are odd. Q, R are odd and P is even. P is nothing but the first place. According to our convention, according to our symbolism, P is nothing but the first digit. P is even. So, what happens in this case? What happens in this case? P must be even. P is in the first place. P, the first place is to be filled by 1 of 0, 2, 4, 6, 8. But 0 is not included. So, in this case, the number of ways of filling the first place is 4, whereas second place and third place, odd numbers can be put here, 4 into 5 into 5. So, in this case, the answer is 4 into 5 into 5. And the last case, case 4. Here P and Q are odd, here Q and R odd, and next case we take R and P are odd. P, R are odd and Q is even. What is the number of ways? Let us examine 3 places. P and R, that is first place and last place, are odd numbers. How many odd numbers are there? 5 odd numbers are there. So, this place 5 ways, this place 5 ways. What about the middle place? It must be even. How many even digits are there? 5. Can you have 0 there? Why not? You can. You can. So, it can also be done in 5 ways. Altogether 5 into 5 into 5. Now, you add all these things. The ultimate answer is now going to be obtained. 5 into 5 into 4 is 100. 5 into 5 into 5 is 125. 5 into 5 into 4 is 100. 5 into 5 into 5 is 125. 125 are 250 plus 200. It is of course 450 is the answer. What is the answer? 450. So it is available in the first option among the given options. So right option is A and the right answer is 450 is the right answer for this question. The next question before us is 47th question, question number 47. A peculiar type of the question. No question of any arrangement or selection is involved here. A matter of calculatory techniques are only involved here. He has given a sum S is equal to (1 by 9 factorial plus 1 by 3 factorial into 7 factorial plus 1 by 5 factorial into 5 factorial plus 1 by 7 factorial into 3 factorial plus 1 by 9 factorial. 1 by 9 factorial. We are supposed to estimate the answer. We are supposed to estimate the answer. What is that? 1 by 9 factorial plus 1 by 3 factorial into 7 factorial plus 1 by 5 factorial into 7 factorial, etc., etc., etc. Observe the options. In the first option, 2 power 9 by 10 factorial is there, and in the second option, the denominator contains 8 factorial, and in the third option, denominator contains 9 factorial, and the fourth option, denominator contains 7 factorial. Well, if 10 factorial can be supplied to the numerator for all those terms in the given sum, beautiful things happen. What are they? Let us observe. S is equal to 1 by 10 factorial into 10 factorial by 9 factorial into 1 factorial plus 10 factorial by 3 factorial into 7 factorial plus 10 factorial by 5 factorial into 5 factorial plus 10 factorial by 7 factorial into 3 factorial plus 10 factorial by 9 factorial into 1 factorial you will be having. Yes, proper observation is needed to estimate the sum. This is equal to 1 by 10 factorial into, is it not 10C1? 10 factorial by 1 factorial into 10 minus 1 factorial. Plus, estimate this, is it not 10C3? 10 factorial by 3 factorial into 10 minus 3 factorial, that is 7 factorial. Proceed like that. This is nothing but 10C5. This is nothing but 10C7. And the last one is nothing but 10C9. Stop. While studying about the properties of NC0, NC1, NC2, NC3, etc., 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 we could have observed beautiful properties of those binomial coefficients. We know that NC0 plus NC1 plus NC2 plus etc. NCn is 2 power n, whereas NC1 plus NC3 plus NC5 plus etc. 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 is equal to NC0 plus NC2 plus NC4 plus and so on. This we say sum of all odd coefficients, and that we say sum of all even coefficients. They are equal, and of course equal to 2 power n minus 1. Of course, this we may have to recollect here to get the answer. In the place of n, we have 10 here. You observe that? 10C1, 10C3, 10C5, 10C7 and 10C9. Almost all the odd coefficients with n is equal to 10 are gathered here. Therefore, the answer must be 2 power n minus 1. And in the place of n, what are you having? 10. Therefore, the entire sum involved in these brackets can be estimated as 2 power 10 minus 1. Let us use it. It is by making use of that result, that standard result, we get the sum to be 1 by 10 factorial into 2 power 10 minus 1. What is 2 power 10 minus 1? 2 power 9. Hence, 2 power 9 by 10 factorial is the correct answer. And the correct option is option A is the correct option, and the correct answer is 2 power 9 by 10 factorial. Therefore, this idea is an important idea to get the answer. Yes, option A is the correct answer. Let us now get ready to look at the next question, that is question number 48. In this question, he asks us to know the number of non-decreasing functions from the set A containing 0, 1, 2 to the set B containing 0, 1, 2, 3, 4, 5, 6 and 7. We want to have just non-decreasing functions. Let us recollect the definition of a non-decreasing function. x1 less than x2 implies f of x1 less than or equal to f of x2 for all x1, x2 in the domain of the function. If that happens, then we say that it is a non-decreasing function. Here, the peculiarity of the problem is the domain contains 3 elements and the codomain contains 8 elements. Yes. Now, we should have f of 0 less than or equal to f of 1 less than or equal to f of 2. Why? Because as there are only 3 elements in the domain, and as we want to have non-decreasing functions, what are the things to be observed? F of 0 less than or equal to f of 1 less than or equal to f of 2. Why should we have like that? Because 0 less than 1 less than 2. Here, naturally, 4 cases may arise. Definitely, 4 cases may arise. What are the cases? F of 0 less than f of 1 less than f of 2. How many such functions are there? F of 0 is equal to f of 1 less than f of 2. Next one, f of 0 less than f of 1 is equal to f of 2. And the last possibility, f of 0 is equal to f of 1 is equal to f of 2. These are the possible cases. These are the possible cases. We should have f of 0 less than f of 1 less than f of 2. Therefore, you have to choose 3 elements from the codomain. First of all, let me recollect what is the domain and what is the codomain here. What is the domain? 0, 1, 2. What is the codomain? B is equal to, what is the codomain? B is equal to 0, 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. All together, how many elements are there? 3 elements are there. How many ways can you choose 3 elements? How many elements are there? 8 elements are there. From those 8 elements, you are supposed to choose 3 elements. Why? Because those images must be in the increasing order. You choose 3 elements first of all. They can be put in an increasing order in one way. How can you do that? In 8C3 ways. In 8C3 ways. The next case, f of 0 is equal to f of 1 is equal to f of 2. Sorry, less than f of 2. In this case, how many elements are to be chosen? It is just enough if you can choose 2 elements in an increasing order. Suppose you have chosen 4 and 5. You define f of 0 is equal to 4, f of 1 is equal to 4 and f of 2 is equal to 5. The character, non-decreasing character is satisfied. Therefore, you are supposed to choose 2 elements there in an increasing order. The smaller element will be fixed as the image for these 2 elements, 0 and 1. F of 0 and f of 1. And the next element, f of 2. So, it is just enough if you are able to choose 2 distinct elements. How can you choose? 8C2 ways. What is the case with this one? Absolutely in the similar fashion. F of 1 is equal to f of 2. As in the previous case, you choose 2 elements. Once again, out of those 2 elements, you fix f of 0 as the first element, f of 1 as the second element, f of 2 as the second element also. Therefore, this can also be done in how many ways? 8C2 ways. And the last, f of 0 is equal to f of 1 is equal to f of 2. What is the case with that? F of 0, f of 1, f of 2, they are all same. So, 0, 1 and 2 are going to be mapped to one particular element of the codomain. How many elements of the codomain are there? 8 elements of the codomain are there. Out of them, how many are to be chosen here? Only 1 element is to be chosen. How many ways you can choose that? 8C1 ways. 8C1. Let us now calculate all of them. What is 8C3? 8 into 7 into 6 by 3 factorial, that is of course 56. What is 8C2? 8 into 7 by 2 factorial, that is 28. What is 8C2? Again 28. What is 8C1? It is 8. You add all of them. What are you going to get? It is, what is this? 3 8s are 24 plus 6, 30. 3 plus 2, 5 plus 2, 7 plus 5, 120. But astonishing, you are not able to get 120 among the options. But you see, the third option 10C3 is just nothing but equal to 120. That you must be able to recognize. Therefore, the right option is option C, and the correct answer is 120, which is equal to 10C3. That you must be able to notice. Therefore, the right option here is the option C, and the right answer is 10C3 is equal to 120. Therefore, this way of splitting the requirement into different cases is the essential thing in making an attack on the question and exploring the answer. Yes, the answer is 120, that is 10C3, that is involved in third option, that is option C. Now it is the time for us to go through the next question, that is 49. Question number 49. What is the exponent of 7 in 100C50? He means in the question the largest exponents of 7 present in 100C50, of course. That is to be obtained. The first option is 0, option B is 2, option C is 4, option D is 16. Let us see. What is the actual number given? 100C50. Using NCR principle, what is 100C50? 100 factorial by 50 factorial into 100 minus 50 factorial, that is 50 factorial. What do you want to have? You want to have the largest exponent of 7, or simply the exponent of 7 in this expression. You have to do two things. First of all, find the exponent of 7 in 100 factorial, and then find the exponent of 7 in 50 factorial. What happens? Let us see. Let us first find. Let us recall and recollect the procedure of obtaining the largest power of a prime number in n factorial. What is the way? It's very simple. It is nothing but the sum of integral part of n by p plus integral part of n by p square plus integral part of n by p cube. You can proceed as many times as you can. If you go on proceed like that, ultimately at some stage that integral part becomes 0. Why? Because n by p square, n by p cube and so on. Going on, you'll be getting a fraction which is less than 1. Thereby the integral part becomes 0. That is the way to get the largest, or simply the exponent of a prime number in n factorial. Now, in 100 factorial we wish to have. So, applying the same technique, this is integral part of 100 by 7 plus integral part of 100 by 7 square plus integral part of 100 by 7 cube and so on. One thing is very clear. 100 by 7 is how many times 7 goes in 100? 14 7s are 98. So 100 by 7 is 14 point something and its integral part is 14. And again 7 square is 49. 100 by 49 means 2 point something. Therefore the integral part is 2 plus 100 by 7 cube is 100 by 343. It is a fraction lying between 0 and 1. Hence its integral part is 0 and then again 0. So there ends the matter. 4 plus 2, that's all. What is the largest exponent of 7 in 100 factorial? It is 16. One activity we could have performed. Now still something is there behind that. Something is there left behind. What is that? We are supposed to have the exponent of 7 in 50 factorial also. Notice that 50 factorial occurs twice in the denominator. We shall see it later. Let us first of all calculate the largest exponent of 7 in 50 factorial. Exponent of 7 exponent of 7 in 50 factorial. Let us use the same thing. Integral part of 50 by 7 plus integral part of 50 by 7 square plus integral part of 50 by 7 cube and so on. 50 by 7 means 7 point something, hence its integral part is 7. 50 by 49 means 1 point something, its integral part is 1. Integral 7 cube means 343. 50 by 343 is a fraction lying between 0 and 1, and its integral part is 0, and you will be getting 0 from there on. So you can stop the procedure here itself. So what is that? 8. Now let us try to understand the sentence. Exponent of 7 in 100 factorial is 16. What does this mean? 7 power 16 is a factor of this. So if you could expand 100 factorial, the largest exponent of 7 is at most 7 power 16, you will be able to see. So in this fraction, in 100 factorial, you will be having 7 power 16. In the denominator, in 50 factorial, you will be able to have at most 7 power 8. 7 power 8 into 7 power 8. 7 power 16 by 7 power 8 into 7 power 8. What is that? 1. What is 1? 7 power 0. So what is the ultimate exponent of 7 in the present number 100C50? It is 0 or 1? 0. There will be no more 7 at all. 7s will be cancelled. The largest exponent is 7 power 16 in the numerator and 7 power 8 into 7 power 8 in the denominator, the presence of 7s. So that in the ultimate number you will be having 7 power 0. Therefore, the exponent of 7 in the given number, that is 100C50, is 0. Therefore, the right answer is 0 and the right option is A. Right option is A. That is the question. The next question is question number 50. In this question, he is asking us the number of zeros in 125 factorial. Number of zeros means the largest exponent of 10. But 10 is a composite number. And the luckiest thing is that composite number could be expressed as a product of 2 into 5, 1 prime and 1 prime, just 2 distinct primes. Yes. If that is the case, to have the largest exponent of 10, nothing but the number of zeros, is largest exponent of 5, because 10 is equal to 2 into 5. Between 2 and 5, the largest is 5. It is enough if you can find the largest power of 5. What I mean to say is, if you are asked to have the largest power of 21 in some factorial, what is 21? You express 3 into 7. Single prime into single prime. So what is the largest prime? 7. And up to have the largest power of 7. Yes, if you are asked to have the power of 77, exponent of 77 in a particular factorial, 77 means 11 into 7. 11 is prime, 7 is prime. Prime into prime, single prime into single prime. The largest one is 11. Therefore, enough to have the exponent of 11 in that particular factorial. By following the same concept here, as we are inquired of the number of zeros is nothing but the exponent of 10. You imagine 10. 10 is 2 into 5. Single prime into single prime. What is the largest prime? 5. Enough to find the largest power of 5, that is the exponent of 5 in 125 factorial. As what is that? Number of zeros in 125 factorial is equal to exponent of 5 in 125 factorial, as we could have discussed just now. Number of zeros is nothing but the exponent of 5 in 125 factorial. Previously, we could have made use of that procedure. It can be traced like this. Integral part of 125 by 5 plus integral part of 125 by 5 square plus integral part of 125 by 5 cube plus integral part of 125 by 5 power 4 and so on. And so on. Let us observe. What is 125 by 5? 25. What is the integral part of that? 25. As it is an integer, so it is 25. Plus, what is 5 square? 25. 125 with 25 is 5. 5 is an integer and the integral part of that is 5 itself. 5. Plus, what is 5 cube? 125. 125 by 125 is 1. Integral part is again 1. That's all. Why? Why? Because what is 5 power 4? It is 625. 125 by 625 is 1 by 5. That is 0.2. Integral part is 0. Hence, this is 0. And from there on, they're all zeros. Altogether, you will be having 31. So, if you could expand 125 factorial carefully, you will be having 31 zeros at the end of that. What is the number of zeros in 125 factorial? It is 31. It's quite interesting. Yes, of course. The number of zeros is 31. Option C is the right option and the right answer is 31. Yes, that's it.